So here's some data from some past statistics semester. I didn't pay much attention. Probably you shouldn't know anyways. But this is like it's the midterm, midterm evaluation that I do for you folks. Actually, I'm going to be doing this during week 4. So here's discussions. The web assignments, the quizzes, exams, and then the current grade as of the end of week 3 usually is. So I just because of what I've looked at, how I've looked at this in the past, exams tend to have some variation. The current grade seems to have some variation, though you look at those grades, those are pretty consistent. They're pretty much in the 90s and must be a good semester. You see how the web assign are all 100 practically. So, I mean, I don't know if that would be good data to look at, but let's look at maybe the quizzes got some variation. We should look at those. We can look at all 3 of them really quickly if we want. So the first thing I want to do is I want to figure out the shape. Is it left skewed, right skewed, symmetric? And sometimes that's a hard thing to decide. So I can do this right in a spreadsheet. I've got videos that I've linked to you, linked for you for a spreadsheet. I'm also what I'm going to direct you to today is some other tools that for people that are less inclined to use spreadsheets, you might like these. I mean, there's plenty of calculators out there. I don't care if you use the one that I'm showing you, but I like the ones that I'm going to show you. And if you like spreadsheets, do spreadsheets. Spreadsheets work slick. So what I've got is, where do I have this? So I'm in where I'm directing you to. This is trying not to make this a private video. Here it is. I think it is. So here it is. So I'm at the summer 2020 statistics course. And then if you click on modules, you see in course resources, whoops, it collapsed on me. You did know that you could collapse those, right? So if you're done with the week, you can collapse it and shrink up the screen a little bit. But in course resources, you see this online statistical tools. If you click on that link, it takes you to some calculators that I've used in the past that people have found useful. And here's a box plot. This one does histogram. This does dot plot. We don't look at dot plots too much in Dr. Stevens' textbook, but they're a nice tool. And that's pretty much it for the first couple of weeks. Then we'll get into chapters 4 and 5. We'll be looking at these. But for right now, since I'm just trying to figure out the shape of this distribution, I think I'm going to go to the histogram one here. Let's open that link up. And this loads. I'm at school, so it ought to load pretty quickly. So with this the nice thing I like about this app, as you'll see in a second, let me show you right now. You see that little draggy box right there, slider? You can change the number of bins on the fly. And then once you find a picture that you like, if you click on show frequency table, here's your frequency table. It's got the bins broken out. I mean, those are kind of weird numbers. I might tweak them a little bit, but I'll just get into that in a minute here. Okay, so let's go get that data that I'm looking at. That was the stock data. I said the quizzes looked interesting, so let's do the quizzes. Control C that. I'm going to come into box plot. I'm going to come down. I'm going to clear out the data that's in there. I'm going to paste my data in. And then and if I want, let's see, what were these quizzes? So you can change what the words are at the bottom. And I'm going to update my data. And it does that. And that's a kind of an uninteresting box plot. So I don't like the gaps. So having gaps in a box plot is not fatal. If you could try to eliminate them, it helps. Sometimes you can't. Like, see, I'm already up to about 5 wide. I don't know. What if I go up to, so there, I kind of got rid of the gaps. Okay, so that's okay. And then what I was going to remember how I said you could change the interval width. We can do that right here. I can change this to, what is it, 7.5? What if I just change it to 7 wide? That makes it a little easier. And then you can change the minimum value. Now I could do 0, but see what happens if I do 0. I get this weird gap going on. So sometimes it's better to not look at all these values to the left. I don't know what the minimum value is. I probably could go look. I'm guessing it's 60-ish. Let's see if I guess 60. I mean, I could go back and look at the actual data, I guess. That's looking good. Actually, I kind of like with how that looks. I see a left skewed distribution because it's got the tail to the left. Sometimes people get confused with left skewed, right skewed. I'll post a picture of a couple of feet that I've used in the past in the discussion forum if I haven't already. So I'm calling that a left skewed distribution. So because it's got the tail to the left. And then the other thing you can do is you can look at statistics. Okay, so look at the frequency table, see how that by setting the interval width to a nice number and setting my minimum to a nice number, I've got some pretty nice values in my table. Now, what you would want to do probably, this is for the exam. I mean, that's why I'm doing this for you. 60 to, I would say 60 to 66.9 instead of 67, and then 67 to 73.9, and that way you don't have 74 in both places. What they're doing mathematically is they're saying less than or equal to 67, then they're saying anything bigger than 67 goes in the next bin. Tweaks it a little bit, you know, it doesn't really matter, but that's your frequency table. And so it does that for you. It doesn't do relative frequency. It doesn't do cumulative frequency. It doesn't do cumulative relative frequency. So that's something we'd have to do by hand with a spreadsheet. But it gives us a quick picture and gets us to a nice number of bins. I read somewhere, and I posted that in this discussion forum for summer 22, I know. I read somewhere that you want to have more than 3 bins or classes and less than 20. And that seems to work pretty well. This is 6, so that's probably pretty good. So because this is a left skew distribution, because this is a skew distribution, I want to use the 5-number summary and the IQR and that 1.5 IQR test, outlier test, to determine whether there's any outliers in this data set. So this calculator does show us some statistics somewhere here. I just got to remember how to find them. Oh, here you go. There's the mean. There's the standard deviation. It doesn't tell us the what we need, the 5-number summary. So in the IQR. So you can do that by hand, or you can go to this other calculator. Let me come back here to the course. And if I click on that other calculator, that takes me out to another calculator in that interactive site. And I'm going to clear the data. I'm going to paste in the data. Hopefully that's still in the clipboard memory. I'll update my box plot. See, that still looks like a left skew distribution. Now, some people will use, let's say Dan says, I say, use tech. Yes, I do want you to use tech. But I also want you to understand what the tech's doing. So to click on this, see that there's no outliers and say, oh, the outlier test says there's no outliers. Well, you haven't run an outlier test. So here's what I would like to see. You are going to click and show the statistics. This is fine. And here's the minimum and et cetera, et cetera. Now, it doesn't tell us the IQR. So the way we get the IQR, you probably remember from reading or looking at some lessons. My open math does it, I know. We do Q3 minus Q1. That tells me how far apart the range of the 2 quartiles, the upper quartile and lower quartile. So upper quartile is 96, the lower quartile is 81. That gives me an IQR, interquartile range of, what is that, 15? And then to run that 1.5 IQR test, we need 1.5 IQRs. So 1.5 times 15. Well, let's see. We grab a calculator, but half of 15 is 7.5. We'll add that to 15. My IQR and my 1.5 IQR is 22.5. So then my lower fence, anything less than this lower fence, is going to be the lower quartile minus 1.5 times the IQR. So the lower quartile for this data set is 81. Minus 1.5 times the IQR is at 22.5. I almost wrote that out again. 22.5. So 81 minus 22.5 is, oh man, 60. I'm sorry, I didn't do this ahead of time. I don't have a calculator right by me. So 81 minus 22.5. I gotta borrow. Sorry, you're making me have to watch me do this arithmetic. So I borrowed 1. Made that be 10. Oh man, I'm having a hard time doing the arithmetic today. Isn't that awful? That became 10. 10 minus 5 is 0.5. I knew that. Sorry. And then I got to borrow this. That becomes 7. That becomes 10. That's going to be 8. And 7 minus 2 is 5. So 58.5. And of course, I don't have anything less than 69. So that's why there's no lower outliers. Okay. Now to do the upper fence, we take the upper quartile, Q3, and add 1.5 IQRs. So 96 plus 22.5. Let's see if I can do this one in my head without doing. So let's see, 22.5 is what? 0.5, that's easy enough. 8 and 11. 118.5 is my upper fence. The maximum is 100. There's no upper outliers. That's why the calculator says no outliers. Okay, so that's that 1.5 IQR test. And again, I use that because I had a left skewed distribution. If I had a right skewed distribution, I would also use it. Now let me go find some data that's more or less symmetric, and then we'll talk about how I know too. Well, maybe I should talk about how I know before I leave this. Do you see the median is 89? The mean is 88. Do you see how the mean is less than the median? In a left skewed distribution, that'll always happen. The mean, these lower values are going to pull the mean down away from the median. See, these lower values distort the mean and the standard deviation. That's why we don't like to use them when we have a skewed distribution. People do, you're going to see it all the time, but they shouldn't. You should be talking about medians and for skewed distribution. That's why when you look at home sale prices and salaries, the federal government, the state governments and federal governments usually use the median to talk about this, the median home price and the median salary. Okay. That's why, because the lower values are pulling the mean down away from the median, or if it's a right skewed, pulling it up away from the median. And you can lie with statistics. That's where that all comes from, is because you're using the wrong measure of center to describe it to make your case. So let me come back and find that symmetric data set. I'll come back. Okay, so this was, I think it was the exams that I copied, and I pasted it into the box plot or the histogram to see what's happening. And somebody might say, gee, that looks kind of left skewed to me also. Okay, and then what you do when you, so it still looks kind of left skewed. Okay, so how can you tell? How can you make that decision? Well, if I'm going to do this, I'm going to I'm going to decrease the number of boxes, the number of bins. Oh, let's see here. To make it look, so I'm going to argue that kind of looks symmetric. I mean, it's a weird symmetric, certainly not normal, but it could be symmetric. And here's another tool you can use to tell. Notice the mean is 94.27. Notice that the median is 94. Not a whole lot of difference between 94 and 94.27. I'm going to make the case that this is a symmetric distribution. If you look at the box plot, that looks pretty symmetric. There's a little tail here, but the rest of it looks pretty symmetric. I mean, 25% of the data is there, 25% of that data there, 25% of the data is there, and this lower 25%, you know, that's got a little bit of stretch going on, but because the mean and the median are so close and the graph is kind of symmetric, I'm going to argue that this is a symmetric distribution just because the relative position of the mean and the medians. So the other thing I want you to keep track of is if you have a left skew distribution, the mean is less than the median, to the left of the median. If it's a right skew distribution, the mean is to the right of the median. And then if it's a symmetric distribution, they're practically the same. And in this case, they're practically the same. So I think that's why I know why I can call this a symmetric distribution. And plus, it'll let me show you the other test. So the other way, the other outlier test is that mean plus or minus 2 standard deviations. That's how Dr. Stevens talks about it being unusual or result being unusual. So to get the lower fence for symmetric distributions, I can take my 94.273, subtract 2 standard deviations, And I didn't take for the upper fence. I could take 94.273 and add 2 standard deviations. Okay, and I'm going to go grab a calculator off screen and do this off screen. I'll be right back here. Okay, so then what's going to happen is I did this and I got, what did I get here? Get my pen going here. For the lower fence, I came up with the 86.785. For the upper fence, I came up with the 101.761. Now I knew there was no grades over 100, so there's no upper outlier. And then I don't remember what the lowest one was. Well, I've got the box plot. I've got this numbers here. I don't have to go look at and the lowest grade was at 87. So since 86.7 is less than the 87, there's also no lower outliers either. So in this case, in both of these distributions, there were no outliers. And I use the appropriate measure of center and spread to do that determination. Okay, so symmetric distribution, use the mean 2 standard deviation outlier test to look for unusual results or outliers. If it's a symmetric distribution, a skew distribution, you can use the median and the 1.5 Iqr test. We also talked about the relative position of the mean and the median to help decide on the shape. So, and one last closing thing, some of you, inevitably, somebody goes online and I don't know what website they find, and it's perfectly fine to find other websites. But let me, somewhere here, it talks about, I don't have it. I don't have it. Some web math is fun or something like that. It talks about positively skewed and negatively skewed. Why does Dr. Steven talk about right skewed and left skewed, and math is fun talk about positive and negative skew? Well, if I have the median, or it's the mean minus the median, and it's a right skewed distribution. Remember, in that case, the mean is a bigger number than the median, so that would be a positive number. That would make it positively skewed. If it's a left, see, right? Because remember, they look something like this. The mean's up here, the median's down here. This big number minus the smaller number will be positive. If it's a left skewed distribution, looks something like that. The mean's down here, the median's up here. That will be the mean minus the median will be a negative number. That corresponds to a negatively skewed distribution. Okay, and I don't honestly care which one you use. I mean, it'd be nice to be consistent with the textbook, but it's just a textbook, so it's more important to do the understanding. It's more important to know which measures, center and spread to use. Okay, so hopefully this helps answer that question and it'll help people.